Chapter 16, aqueous ionic equilibrium. So this first section, a lot of these modern textbooks, they put in these things, these little sections, and they kind of feel like they're little touchy-feely things to me. Like, oh, yeah, we don't really need to talk about this. But I think it's good to talk about this little section because it does help us to see how these weird things we're talking about in chemistry actually have application in real life. And so we're going to talk about this. I think it's a good introduction. So you all, I'm assuming, know what antifreeze is. Yep. Right? It's that like the day-glow yellow stuff that you put in the radiator of your car. And if you have a leak in your radiator, it runs out on the ground, right? Well, maybe you didn't know, but every year thousands of cats and dogs die from ingesting antifreeze. Because it turns out that ethylene glycol, which is the active ingredient, it's mostly ethylene glycol with some color and stuff so you can see it, and then a bunch of water. It has a sweet taste. So it's not like a lot of poisonous things that taste bad.
And it smells sweet.
And it smells sweet. And so, hungry, thirsty cat or dog smells this stuff. And they're like, oh, hey, I'll taste that. And so they lick it up off the street. Or if it's not stored properly, they get into it. And they end up dying. And so what's going on with that? Well, if we look at this molecule, we see this OH on each end. This is actually an alcohol. It's called a diol. It's a dialcohol. It has two alcohol groups on it. So your body can metabolize it like it does with an alcohol. And so the first symptoms of ethylene glycol poisoning is an appearance of drunkenness. So, might seem funny, drunk cat, drunk dog. My dad used to collect beer bottles in the ditches and pour all the little drips together and feed them to the chickens just to be able to see them run around drunk. Now we know that's cruelty to animals, but that was, back like... Yeah, it's okay for people to do that to each other, but not for us to do it to animals. So the first symptoms are drunkenness, and that wouldn't be so bad, but what happens next is that ethylene glycol is metabolized into glycolic acid. So glycolic acid is an acid, and it gets into the bloodstream. And it affects the acidity of the blood. Blood has a very particular pH range. In humans, your body regulates your blood pH between 7.36 and 7.42. And it gets out of that range, and you're going to be ill. If it drops below 7.0, you're going to die. And so your blood acidity is really important. Well, your blood pH is maintained by buffers because a lot of the things that our bodies metabolize and the byproducts that produced are acids. And so your body is pretty good at dealing with acids getting into your blood. It's maintained by buffers. And we're going to talk a lot about buffers in this chapter. What is a buffer? Well, in real life, what's a buffer? It's like... Okay, so a buffer that buffs out a car, right? What's another use of buffer? Like a bump, a guard, a cushion. It protects things from hitting into each other. Well, in chemistry, what a buffer is it's a chemical system that resists pH changes. So it helps the pH to not change so much. It buffers. So it kind of keeps it in this range and keeps it from getting out of line. And it does this by neutralizing an acid or a base that gets added. And we're going to see in this chapter today how that works. But for now, that's all you need to know. So in the bloodstream, the most important buffer is a mixture of carbonic acid and bicarbonate ion. And so what happens, here's carbonic acid. If you add a base, the carbonic acid will neutralize the base, forming water and bicarbonate ion. Well, the blood also contains bicarbonate ion. If you add acid, the bicarbonate acid neutralizes the acid, forming carbonic acid. And so we've got this back and forth thing. It can neutralize acid, and it can neutralize base. So this is great. But if you have enough glycolic acid coming into the bloodstream, it's going to use up all the bicarbonate ion and overwhelm the buffer system. That's going to cause the pH of the blood to drop. And the reason that that's especially dangerous is because of another equilibrium. So the equilibrium between hemoglobin and oxygen is dependent on the acidity level. So if we have excess acid, it's going to push this equilibrium to the left. It's going to reduce the ability of the blood to carry oxygen. And so what is sometimes observed is that the cat or the dog begins to hyperventilate. They begin to breathe faster. They're not getting enough oxygen because their blood can't carry the oxygen because it is too acidic. And then comes coma and death. And so this is it's tragic. Well, what can you do if your cat or your dog gets into the antifreeze? You can get them drunk with real alcohol. Yeah, seriously. So one serious treatment is the administration of ethanol. Ethanol is the alcohol that's in vodka and gin and any other alcoholic drinks that humans drink. It's really the only alcohol that's safe for humans to drink. It's still a toxin, but it doesn't kill us most of the time. So we still drink it, right? So you administer ethanol. Ethanol is also metabolized in the liver, but the enzyme that metabolizes the alcohols would prefer to metabolize ethanol. So you get enough ethanol in there, and it keeps the enzyme busy metabolizing the ethanol, and it lets the ethylene glycol just go out into the urine and not be turned into glycolic acid. So,
They die from that.
well, they might have a hangover, but yeah, you can save them. You can save them by getting them drunk. Are they going to enjoy the alcohol? No, they're not. Any questions?